Okay everyone, so right now this video will be talking about mutually exclusive events and the addition rule. Now the addition rule is when it comes to probabilities of events that deal with an or situation. So when something or another thing happens, we use the addition rule as compared to something with an and. So just keep that in mind as we get to the addition rule. Okay, first, what is a mutually exclusive event? Mutually exclusive events are two events that it is impossible for them to occur at the same time. So just think about some examples of that, but this one is saying that the intersection of A and B, the two events A and B, is going to be empty. There's nothing that's going to happen both A and B. And then the probability of that happening is 0. Just another thing to think about. The example that quickly comes to mind is if I toss a coin, the mutually exclusive events are whether it lands on heads or it lands on tails. There's no way to land on both. So it is not possible for a coin to land on both, and so these events are mutually exclusive. They will have no intersection, and so the Venn diagrams for mutually exclusive events can be like two circles that do not intersect, do not overlap. And so here I've created a universal set that we've seen before, and now my two sets are A and B. A is the negative integers and B is the positive integers. Now if 0 were in here, yes, there may be some overlap, but for this example, I don't have anything that is neither negative nor positive. So can't be both. And so in this case, I'm just going to have non-overlapping circles. So here are my negative numbers. Here are my positive numbers. There's no both. So the intersection is empty. Nothing is both negative and positive. Okay, now we're going to switch gears, and we're talking about intersections and kind of and. Now we're going to say or. And remember, or is that union, the big U. The addition rule is when one event or another, we're asked whether the probability of one or another. And when it's mutually exclusive, like we talked about, and these shapes show that there's no intersection, the or, which is the union of A and B, the probability of that is simply the addition of the probability of A and the probability of B. So that's our simplest case. When mutually exclusive events, and we're asked to say, is it A or B, we simply add them. Now with non-mutually exclusive events, here I represent that with an overlapping Venn diagram. So this would say we have some information inside here that represents the and. So A, B, and A and B. So here it's a little bit more complicated. So the or, A or B, probability of that is the addition of A and the probability of B, but we subtract that and. So A, probability of A, plus the probability of B, minus that intersection, that overlap inside. Because think about it, if we've added A and we've added B, we've added this middle section twice. So we just got to take it away one time, and then we'll have that whole set of the union. So we'll look at an example with a mutually exclusive event because it's the simplest. What is the probability of rolling a 3 or an even number on a dice? And generally when you see a problem like this, they won't tell you this is mutually exclusive. You'll have to determine that. So can we get a 3 and an even at the same time? No, there's no way, because 3 is an odd number, and therefore the even set is not going to overlap. So we're going to call our event A rolling a 3, and our event B is rolling an even. And we'll find the probabilities of each one. The rolling a 3 is 1 out of 6 times. Remember, a dice has 6 sides, so only one of those sides has 3. Now, rolling an even, we can roll a 2, we can roll a 4, we can roll a 6. So we have 3 options out of the 6 total that are even. And I've reduced this fraction to 1/2. So we'll go back to our mutually exclusive addition rule formula, the probability of A or B is equal to the probability of A plus the probability of B. So that's probability of A, 1/6, plus 3/6 probability of B. Now I kept it as 3/6 just because if I'm adding fractions, my denominators must be congruent. So I have the 6's are the same. That means I can go up the top, add 1 and 3, and carry the 6 over. So 1 plus 3 is 4, and 6 stays as my denominator. Well, I'm going to reduce this again just because sometimes that's easier to think about. 4 times out of 6, what about 2/3? Okay, same thing, and generally your answers will be in reduced form. So to summarize, this question is asking about whether one event or another will occur. So we add the mutually exclusive probabilities. Now an example with non-mutually exclusive events. So some things that can be both at the same time. Okay, what is the probability of rolling a value less than 4 or an even number on a dice? So same situation, but different requests. We're looking for values less than 4 or an even number on a dice. Remember, values less than 4 does not include 4. So like before, we define our events. Event A is the rolling less than 4, and event B is rolling an even. The probability of this event rolling less than a 4 is our 3 numbers less than 4 over the 6 total outcomes possible. The probability of rolling an even is the 2, 4, and 6, like we talked about before, over the total number of outcomes in rolling a dice. Now the both, if it's less than 4 and even, there's only one number that happens to be in that situation, and that's the number 2. How do I roll number 2? The only way is that one way out of 6. So the probability is the number of outcomes that have 2 over the total outcomes for rolling a dice. Now I'll have my non-mutually exclusive addition rule formula where A or B is the probability I'm looking for. That is equal to the probability of A plus the probability of B minus the probability of both A and B. Fill in the numbers. I got 3/6 from these two right here minus 1/6 over here. So remember, with adding or subtracting fractions, if my denominators are the same, I simply add the numerator or subtract the numerator. So 3 plus 3 minus 1 is 5. So that's my answer. And same thing, just to summarize, this is an OR, and so we add. When we're asked whether an event or another will occur, we add the event probabilities and subtract the probability of both. One more example with non-mutually exclusive probability. So this is going to get into a lot of word problems, so you just have to figure out what is it asking. Here it says a study finds that the probability of a bike getting a brake defect is 4%. The probability of a chain defect is 3%, and the probability of both a brake defect and a chain defect is 1%. So we have the probability of one thing, a brake defect, the probability of the other thing, a chain defect, and the probability of both. So those, remember, are our 3 pieces to the non-mutually exclusive probability addition rule. So it's asking, what's the probability of getting a brake or chain defect? Or, so we're doing addition. First event, brake defect, right here, brake defect. Event B, chain defect, right here. Now I want to figure out what the probability of that brake defect is. It came out of here. 4% as a decimal is 0.04. Remember, divide percent by 100 to find the decimal. The probability of B, which is the 3%, is the chain defect. So again, 3 divided by 100 to get my decimal. And they gave me the probability of both A and B, which was right here. Both a brake defect and a chain defect is 1%. So I take my non-mutually exclusive, because we have both, remember there's something there, and I add the probability of A and the probability of B and subtract out the intersection of both of them. So the probability of A is 0.04 plus the probability of B, 0.03, minus the probability of both, 0.01, which is 0.06. And that's my answer. Okay, there you have it. So mutually exclusive events are things that cannot happen at the same time. So there's no and. But again, you can have an or. And then the addition rule is dealing with ors. And you add probabilities if they are mutually exclusive. It's real easy. And then when they're non-mutually exclusive, meaning they can happen at the same time, we add them and then subtract that both situation. Okay.